All right. Good afternoon, everyone. So we are here at week 6 na of the semester. Though we are still in the study guide for week number 5. Siguro madidelay talaga tayo ng isang full week. But no problem with that. We can adjust later, and I want to discuss everything in details rather than just breeze through the topic. So yeah, but for those who are doing things in advance, okay lang. Medyo bagal-bagalan nyo lang ng konti para mag-sync tayo, right? So because last week we looked at some methods of proof, and I think we finished the proof by contraposition. Again, this is a tool that allows us to prove a conditional statement. Kasi meron dalawang paraan, or actually we have seen, hindi lang dalawa, pero we have seen two ways on how to prove a conditional statement. So these are statements of the form P implying Q. And what we did last time, or early last week, is to use a direct method or a direct proof. Okay. For conditional statements, wherein we assume P, right, the premise, and from there we want to use some established theorems, some rules of inference or rules of equivalence to show or to arrive at the statement Q, right? Ganun natin, ito yung direct approach sa pagpo-prove ng conditional statements. Now, sometimes, starting from P, it's hard to show the statement Q, right? So, nakita natin yung ilang examples kung saan mahirap mag-start kay P, tas ipakita si Q. So there we got a different technique, and that is called the rule of, or the proof by contraposition. Okay. Sulat natin dito, contraposition. And in the proof by contraposition, we assume the negation of the consequent. So ina-assume natin yung not Q, and then we want to show, or we want to arrive at the negation of the antecedent, right? And the proof by contraposition is based on the rule of transposition, right? Kasi alam natin from the rules of equivalences, now P implying Q ay equivalent lamang sa statement na not Q implying not P, right? So when we say equivalence, when this is true, then this is true. If this is false, then the other guy is also false, right? So kaya equivalent sila. So it doesn't matter if you prove this, then this statement automatically follows. Or in some cases, it's easier to start with not Q and show not P. And if you're able to do that, as what we did late last week, yung proof nito ay sufficient na para ma-prove yung P implying Q. All right? So that adds another tool in our toolboxes kung paano mag-prove ng conditional statements. So for today, we'll encounter yet another way in order to prove conditional statements. And actually, this can also be applied to other statements. Kahit yung simple proposition lang, posibleng gamitin natin itong method of proof na to, which could be easier than the direct proof or the contraposition proof, right? Just a word of caution, right? So sa direct proof at sa contraposition, hindi natin ina-assume si Q. Walang method of proof na nag-a-assume ng Q, right? So you never assume what is to be shown in order to prove itself. Sa direct proof, nag-start ka sa premise. Sa contraposition, nag-start ka sa negation ng gusto mong i-prove, tapos ang goal mo mapakita yung negation ng premise, right? Nowhere, or there is no method of proof that you will begin with Q. Kaya pag sa proof nyo nakita ko na nag-start kagad kayo kay Q, medyo duda na ako. And probably I won't be interested too much into reading the rest of your proof kasi alam ko there will be a problem there, right? Kasi parang I-sword ngayon sa isang mathematician na if you want to show Q, you start at Q, that is almost nonsensical, right? So I hope nobody will do that, right? So yeah. So I was checking the calendar last week with my other class, and it looks like it's almost time for the first problem set, right? So nawala sa isip ko to last time, kaya sorry hindi ko na-inform kayo agad. And based on my negotiations with the other lecture, so ang gagawin natin, or ito rin yata yung nakalagay sa course guide. So I'm thinking about the first problem set to be on October 25. It will go live in Canvas. at 8 a.m. on October 25. And then it will be due on October 27, Wednesday, right before midnight. Okay. So also a reminder, I already gave you the first problem in the problem set, yung problem set 1.1. Due siya on the 27th then, next Wednesday rin, 11:59 p.m. And then, so yun na yung first item. So I'll give you 4 more problems and that will be available on October 25th. Okay? So yung idea dun sa 4 problems na yun, I will design them. Hindi ko pa sila nagagawa. But I will design them so that you will be able to finish them in probably around 1 hour. Okay? So that means you will have 1 hour per problem. So kailangan nyo ng around 4 hours para dun sa problem set. Of course, you can go beyond if you think you need more time. Pero ito yung ideal. Matapos nyo siya in 4 hours. So, kaya yung 3 hours nyo sa Monday na lab, ika-cancel ko na lang yung worksheet 6. So, hindi nyo na kailangang isubmit si worksheet 6 para makapag-focus kayo sa Monday during your lab classes dun sa paggagawa ng problem set 1, the rest of the items in the problem set. So, you will have 3 hours on the lab on Monday. So, I expect you to be able to finish around 3 problems. Tapos yung Tuesday at saka yung Wednesday, hanapan nyo na lang ng isang oras kung saan nyo isisingit yung pang-apat na problem. Okay lang ba yun sa schedule nyo? My other the other section, dalawa yung Math 101 lecture classes na hinahandle ko ngayon. Nag-agree na sila dito. But how about you guys? Baka meron kayong mga special requests dyan. Tinanong ko sila kung di ba kailangan nyo ng 4 hours? Tinanong ko sila kung gusto ba nila na i-cancel ko yung lecture on Tuesday, Thursday yung lecture nila Para magkaroon pa sila ng 1 hour, ika-cancel ko sana yung lecture ko sa kanila ng October 26. Pero ayaw nila. So kayo ba? Gusto nyo ba mag-cancel tayo ng lecture sa 27 or okay lang na pagpatuloy na natin? Parang nabudol ko sila na masaya naman sa lecture so wag na nating i-cancel. So, mukhang nag-agree naman sila. So, budol is real. How about you guys? Do you think you can find 1 hour dun sa Tuesday, Wednesday para isingit yung isang item? Okay, so I take those reactions as a yes. Thank you guys. Para makahabol-habol rin din ako dun sa study guide. Alright? So the coverage of problem set 1 will be until what we'll finish on Friday. Yun na lang yung deal natin. Okay? So, labas ko siya ng 8 a.m. on Monday. And then, deadline is Wednesday, 11:59 p.m. So, if you think there are some reasons for which you cannot comply with the deadline, just let me know. Kasi automatic mag-close kay Canvas yung submission ng October 27, 11:59 p.m. So, if you have some valid reasons why to miss the deadline, say, vaccination yon on Tuesday and you were not feeling too well Tuesday and Wednesday, so just let me know. I can make appropriate accommodations for you. So sabihan nyo lang ako. Pero I'll be a little bit strict with the deadline. But if you really have some unavoidable circumstances, you're not feeling too well, so just let me know. I can make appropriate accommodations or adjustments for you. Just let me know. Gusto ko lang masanay kayo na nagsasabi kayo na hindi namin ina-assume na kailangan nyo ng deadline. Alright? So, yan. Sabihan nyo na via email or via Teams chat. Okay lang yan. Right? Pero yun nga, para medyo magaan din, cancel natin yung worksheet 6. But I think worksheet number 6 might be a good exercise. Tama nga ba? Ito na yung worksheet 6, no? Yung nandito. Or worksheet 5 pa lang pa. But that might be a good practice. I don't know what the content of worksheet 6 is, pero let's forget about that for now. But if you think that will be a nice review, then go ahead and try worksheet 6. Okay. Oh, by the way, PMI na yung worksheet 6. Okay, thank you, Frizel. Wag niyo na munang intindihan yung worksheet 6. I doubt that we will be able to completely tackle PMI by Friday. So baka hindi ko na siya isasama talaga. Okay? So makakaligtas kayo yung PMI yung pa naman yung medyo challenging a little bit sa problem set. But let's just put it, let's defer PMI for for the next problem set. Okay? And then just watch out for the instructions kasi hatiin namin yung grading ng problem set. Ako yung nag-check ng problem set 1.1. So kung may mga reklamo kayo, sa akin kayo magreklamo. Then probably dun sa 4 items na due on the 27th, siguro kukuha pa ako dun ng isa na i-grade. Then I'll leave the 3 items to be graded by your lab instructors. So mayroong at least 2 submission bins sa Canvas na makikreate para sa problem set 1. Okay? So yung isang submission bin ay para sa akin, tapos yung isang link ay para dun sa submission sa lab instructors. Tatanong pa sa kanila kung anong gusto nila na yung 3 items sama-sama sa isang PDF o hiwa-hiwalay na submission. So sabihan ko kayo on Friday kung ano yung preference ng lab instructors niya. Okay? But definitely there would be one separate bin para ako yung mag-check nun. All right? So more on that on Friday or on Tuesday. On Wednesday. Hindi pala pwede kayo ng Wednesday, no? Kasi na talaga yung deadline. Tapos 5:30 tayo. But anyway, I'll let you know. So too much of that. So let's go back to the worksheet. At sinabi ko nga kanina, I'll introduce a new method of proof. And this is a nice and fascinating method of proof, which paved the way for proving some mathematical statements na otherwise mahirap i-prove. And this is what we call the proof by contradiction. It is such a nice tool that the mathematician Hardy said that it is a far finer gambit than any chess gambit. Meron ba dito mga chess players? So kung familiar kayo sa gambit na tinatawag sa chess, or kung nanood kayo ng Queen's Gambit nga ba yung sa Netflix na series, which is a good one, and by the way. So parang sa Gambit, nagsasacrifice ka ng isang importanteng piece sa chess. Usually it's the Queen's Gambit, wherein you sacrifice your queen to get a tactical advantage over your enemy. Kasi sa chess, napaka-savvy natin mag-capture ng queen kasi yun yung pinaka-powerful na piece insofar as movements are concerned. Siya yung may pinakamaraming possible movements. So usually we sacrifice the queen, and it's a very shiny sacrifice that most players will take the chance to capture the queen, and you give it in order to achieve some tactical advantage leading up to a complete checkmate, right? Sabi ni Hardy, yung proof by contradiction, mas maganda siya sa kahit anong gambit or sacrifice sa chess. Sa chess, we are just offering a pawn or even a queen, right? Pero in a proof by contradiction, a mathematician offers the entire game. Ano ba yung game natin sa proving? We are trying to prove that a certain statement is true. Now, sa proof by contradiction, i-offer natin yung game. Sabi natin, kunwari, mali yung gusto kong i-prove. And what we will show is that that assumption or that supposition na mali yung gusto nating i-prove should not happen because something wrong will occur, or there is something absurd that must be accepted to be true if the theorem is false. So ang idea, gusto kong i-prove halimbawa si statement P, right? I want to show P. Sasabihin ko sa proof by contradiction, kunwari, mali si P, right? And then I'll use some arguments, some valid arguments, established theorems, coming from that supposition that P is false. And then I want to arrive at something absurd. I want to arrive at something that cannot be true. All right? Para masabi na, okay, kung tanggapin mo na mali yung theorem, merong something na mali. Guguho yung foundation ng mathematics. Usually, you'll find a contradiction with some other established facts. And that will lead us to say na, okay, hindi pwedeng maging mali yung gusto kong i-prove. Kasi kung mali siya, magkakaroon ako ng contradiction sa isang statement na alam na natin to be true in the first place, right? So this proof technique is based on the law of excluded middle. Does anyone remember what the law of excluded middle is? Any volunteers? Tandaan niyo yung law of excluded middle. Okay, Neil Christian?
Sir, yung ano po yata, sir, yung P or not P.
Okay, P or not P. Or in the words of Shakespeare, to be or not to be, that is the question. Pero kung mathematician ka, sasabihin mo, mali yan si Si Shakespeare, to be or not to be is not a question. It is a tautology, right? It's the law of excluded middle. P or not P. So, doon siya naka-base. Kasi pagka inassume mo, kung gusto mong i-prove si P, sabihin mo, kunwari, mali si P. So, i-assume mo si not P. And you will show that not P is impossible, or the truthfulness of not P is impossible. Therefore, hindi pwedeng maging totoo si not P. Ito, tautology to. So, that forces us to accept the truthfulness of the statement P. Okay? So, in summary, sa proof by contradiction, ina-assume natin na mali yung gusto nating ipakita, and we will be searching for something wrong. Okay? So, and because we are not attacking the problem head-on, ang tawag dito, ang other words for, or other name for the proof by contradiction is an indirect proof. Because we are not attacking the problem by showing what we want to prove is true. We want to show that the falsity of the statement that we want to prove is impossible to happen. And so by the law of excluded middle, we must accept the truthfulness of such. Okay? Kaya siya ang tawag indirect proof. So some statements are easily proven using indirect proof, pero almost impossible to be proven by direct proof. Kaya medyo dapat ma-master niyo yung indirect proof. So let's try some examples. So let's start with example 29. Example 29, gusto nating ipakita that for any positive real number x, this statement is true. Okay, yung gusto nating ipakita. The inequality x over x plus 1 is less than x plus 1 over x plus 2. Well, if we want to do a direct proof from it, siguro mag-start tayo sa isang preliminary analysis. Gusto nating tingnan ano yung implications nito, kumuha ng biconditional statements, tapos mag-work backwards at mag-start sa isang bagay na alam natin to be true. Right? Pero kung ayaw nyo mag-preliminary analysis, we can do an indirect proof or a proof by contradiction, for example, 29. So, and then we can write the proof this way. Nandito na yung proof sa work text, but I'll try to do it my way. Okay? Proof. Okay. And then since sabi dito, for every positive real number x, so I will assume, or I will consider an arbitrary positive real number x. Remember, our symbol for positive real numbers is r plus, all right? So kuha ko ng arbitrary. And then I'll do it by contradiction. So I will suppose that the statement to be proven is false. Ito yung gusto nating ipakita, all right? So kunwari, sabihin ko na siya ay false. So I will suppose, for the sake of contradiction, so my symbol for a supposition for the sake of contradiction is a $sign. So isusuppose ko yung negation ng gusto kong i-prove para makahanap ng isang contradiction, right? And for me, this is my usual signal that I'm doing a proof by contradiction. Ginagamit ko lang yung $sign para sa suppose, usually kapag ka nagpo-prove ako by contradiction. Okay? Kaya ang basa ko sa dollars, hindi lang basta suppose, pero suppose for the sake of contradiction that x over x plus 1 is greater than or equal to x plus 1 over x plus 2. Okay? So which is basically the negation of the statement that is to be proven. Okay? So babalik tayo dun sa warning ko kanina. Walang method of proof na nag-start sa assumption nung gusto niyang ipakita. And that still apply for the proof by contradiction. Ang ina-assume natin ay yung kabaliktaran na gusto kong i-prove, right? Gusto kong i-prove itong statement na to. So what I will assume for the sake of contradiction is that this is false, na hindi less than yung nasa kaliwa kesa dun sa kanan, all right? And that not being less than can be translated to greater than or equal to, all right? So here, sinupose natin na totoo itong inequality na to. Then since this is true, I can multiply both sides by x plus 1 times x plus 1, right? Or you can say na then we can multiply both sides by x plus 1 times x plus 2. And x plus 1 times x plus 2 is always positive because x is a positive real number. And so if I multiply the left by x plus 1 times x plus 2, cancel yung x plus 1. matitira lamang si x times x plus 2. And if I multiply the right-hand side by the same quantity, maka-cancel yung x plus 2, matitira lamang ay x plus 1 quantity squared. Alright? And since yung pinang-multiply natin na x plus 1 times x plus 2 ay isang positive real number, the inequality won't change. Alright? So if we will assume this to be true, then this must also be true. And I think it's still fine so far, or hindi pa obvious na may mali. But once I expand this expression, I'll see that the left side is equal to x squared plus 2x, while the right-hand side is x squared plus 2x plus 1. And here I think you can see the glaring contradiction or the absurdity in this statement. Bakit mali itong statement na to? Bakit ko kayang sabihin na absurd itong statement na to? Any suggestion? Or hindi niyo pa nakikita kung bakit mali ang statement na yan? Oh yes, John Raphael.
Sir, I believe the right side of the equation will always be greater than x, the left side, since the right side will always be one more unit than the left side.
Okay, thank you, John Raphael. Ano pala nickname mo para maalala ko?
JR po.
Okay, thank you, JR. So, yun, tama si JR. Dahil yung right-hand side ay laging mas malaki ng isa dun sa left-hand side, mali etong inequality na to. Right? And this is something is false, right? Or if that is not clear to you, I can subtract x squared plus 2x from both sides. So this guy will be 0, and then this guy will be equal to 1. Pwedeng dito kayo magtapos, right? And this is, I think, a more obvious contradiction. So, lagyan ko yan ng blitzkrieg or a lightning arrow, right? Or Harry Potter symbol, right? So ito yung symbol para sa contradiction. So this is the sign na meron ng mali. Okay? And bakit nagkaroon ng mali? Yung 0 ay hindi greater than or equal to 1. And this is brought about by the supposition that what is to be proven is false. Okay? So kung mali yung gusto nating i-prove, dapat tanggapin natin na si 0 ay mas malaki kaysa kay 1. But we cannot accept this kasi guguho yung foundation ng math, right? Yung mga natutunan natin before, hindi na sila mag-hold. Established na sila to be true before. So we cannot accept the supposition, this supposition that we have earlier to be true. So therefore, by the law of excluded middle, we will be forced to accept that x over x plus 1 is strictly less than x plus 1 over x plus 2. Okay, and that ends the proof. All right, is that clear, guys? Of course, you could have chosen to do a direct proof for it, pero minsan mas eleganteng tingnan yung proof by contradiction kasi walang PA. Wala kang tinatagong intermediate steps, right? And sometimes there are statements that are more easily proven using contradiction rather than direct. Kasi yung iba parang imposible nga ma-prove using a direct method. Okay? So let's try another one. Okay, so let's try this one. I guess we have proven a similar statement to this last time. Parang x plus 3 over x greater than or equal to 6, if I'm not mistaken. And then I think we did the direct proof for that. I think a contrapositive proof might be also good for this one or for the statement similar to this one. Pero try natin siya by contradiction. Okay, so the statement is claiming that it should be true for any positive real number x. So I will start by considering an arbitrary positive real number x. And then I'll do a proof by contradiction. So what would be my supposition here? So I need to suppose, for the sake of contradiction, that what? Any volunteer? Okay, Prince. Okay, I think magta-type si Prince. Ikaw lang, Prince. Kakape muna ako. Okay, thank you, Prince. Sabi niya, x plus 1 over x plus 1 over x is less than 2. That's correct. This is our supposition for the sake of contradiction. Ninegate ko lang yung conclusion ng theorem. Alright? Gusto mong ipakita ng theorem na totoo tong inequality, pasaway tayo. Kunwari, mali siya. Okay? Kung mali siya, dapat ito ay totoo. Right? And then since we are trying to prove this statement, dapat makahanap tayo ng something na mali out of this supposition. Okay? So what would be my next step here? Any suggestion? So mula dun sa supposition ni Prince. Yes, Axel?
Subtract both sides by 2 po. Kaya ang kalabasan po x plus 1 over x minus 2.
Okay. Medyo mahina, Axel, pero tama ba? Sabi mo ay i-simplify ito?
Ay, hindi po subtract both sides by 2 po.
Subtract both sides, subtract 2 from both sides? Sige, try natin. So, x plus 1 over x minus 2 less than 0.
Yes po.
And then, ano kaya yung susunod? Iba yung nasa isip kong proof pero go ahead.
I multiply both sides by x.
Okay, then multiply both sides by x. All right, and that is valid. Why? Bakit pwede ako mag-multiply both sides by x? Or dahil trip mo lang mag-multiply ng x both sides?
Para kalabasan po dyan. So, pwede po natin siyang gawing quantity x minus 1 raised to 2 less than 0.
Okay. Yeah, I think that's fine, Axel. Thank you. Yeah, gusto mag-multiply ni Axel ng x to both sides para makakuha ng mas magandang form. Nobody wants to work with fractions, right? Mas maganda yung form na to kasi tama siya. Mas okay to na i-factor, right? Or mas clear na kaya ko siyang isulat as x minus 1 quantity squared less than 0, right? But what help will that give us? What can we say from this step? Anyone? Bakit nakatulong yung suggestion ni Axel? Ano ba tong meron tayo ngayon? Or how do you think we should proceed? Okay, Neil Christian?
Sir, since square po yung nasa left side, sir. Ibig sabihin, sir, always greater than 0 po siya.
Okay. Thank you, Neil Christian. Medyo i-amend ko ng konti yung statement mo. Kapag ka meron kang something squared, lagi siyang greater than or equal to 0, right? Posible kasi siya mag-0. Pero ang usapan, kapag ka nag-square ka ng kahit anong real number, ang sagot ay laging non-negative, right? But this statement is clearly contradicting that fact because it is saying that x minus 1 quantity squared is negative. And we know that this cannot happen. So we can label it as a contradiction. All right? So ibig sabihin, kung mali yung theorem, ibig sabihin dapat tanggapin natin ng x minus 1 quantity squared ay negative, which we cannot allow to happen. So again, by the law of excluded middle, we will be forced to accept the statement to be true. Ibig sabihin, mali itong supposition natin. Dahil mali yung supposition natin, we don't have any choice but to accept that x plus 1 over x must be greater than or equal to 2. End of proof. All right. So I hope you are getting the hang of it and appreciating proof by contradiction. Okay. All right. So yeah, this is a classic example. But before I go to this proof, okay, meron akong kailangang result, yung nasa illustration 31. And I think we have seen this statement from last time already. Tama nga ba? Pinprove natin to by contrapositive. Na kapag ka meron kang a squared na even dapat si A ay even din, right? So I think we mentioned na medyo mahirap itong i-prove directly. Kasi ang direct proof ay P implying Q kasi siya. So ang direct proof, i-assume ko si P, ipakita ko si Q. Pero I think we tried it. Tama nga ba? Correct niyo kung mali ako. Tinry na yata natin to. Tapos nawalan tayo ng expression para kay A squared. Kasi sabi natin si A squared ay even, so that means A squared must be twice an integer. Pero gusto nating makita ano yung behavior ni A. So kapag ka in-square root mo yung A squared being equal to 2 times a K, square root of 2K, hindi natin masabi na even yon. Okay? So kaya medyo may problema na i-prove siya directly. Okay? So kaya I think we prove it using contraposition. And then in illustration 31, the same result, the same theorem was proven using contradiction. Okay? So basahin nyo na lang yung proof ng 31. Isa siya, isa siya alternative recipe para sa proof. So bahala kayo kung paano niyo siya gustong i-prove by a contrapositive or contraposition. But I will need this proof in order. I will need this result in order to prove a bigger theorem, which is in illustration 32, right? So sinasabi lang nito kapag ka meron kang even, kapag ka si A squared ay even, dapat mag-follow na si A ay even din. So tandaan lang natin siya, right? And I'll go into the main result, or this nice result. Square root of 2 is irrational. Okay, there you go. Kala ko nag-stuck na yung screen ko. Okay. During the times of the Pythagoreans in ancient Greece, they all believed that all numbers are rational. Yun yung paniniwala nila. Na lahat ng numbers kaya nating isulat as a fraction or as a ratio of two integers. And so they believe that square root of 2 can be written as a fraction. Hindi lang nila alam kung ano yung dalawang integers na yon na kailangan nilang ipag-divide para makuha si square root of 2. Alright? And then the Pythagoreans believed for a long time na rational lahat ng numbers, including square root of 2. And then there comes this guy. His name is Hippasus. Kalimutan ko yung spelling. Sorry. Search na lang yung storya ni Hippasus. Alright? Si Hippasus, sabi niya, ang square root of 2 ay hindi rational. So he is going beyond, going against the popular belief. And Pythagoreans consider their math sacred. So inisip nila, hindi pwede na maging irrational yung square root of 2 kasi lahat ng numbers ay rational for them, right? And then there comes this guy nga si Hippasus. Sabi niya, hindi. Ang square root of 2 ay irrational. Hindi natin siya kayang isulat as a ratio of two integers. And legend says that Hippasus was murdered dahil dun sa claim niya na yon. And there are other legends, hindi ko alam kung totoo, pero nabasa ko lang somewhere. Fact check nyo na lang ako. Uso naman ngayon yung fact checking, no? So, parang pinatay siya, nilunod siya. Kasi sa claim niya ng square root of 2 ay rational. So for now, buti na lang, nasa modern era na tayo. We already know that square root of 2 is irrational. So hindi na tayo mahihipasus pag pinurove natin tong statement na to. Alright? So imagine doing a direct proof for this one. So kung gusto nating ipakita ni si square root of 2 ay rational, dapat ipakita natin na imposible na masulat siya as a ratio of two integers. And that is hard to do, right? Parang ang hirap ipakita na imposible ang isang bagay. Kasi pag hindi mo mahanap yung P over Q na equal kay square root of 2, hindi ibig sabihin nun na hindi siya rational number. Ang ibig sabihin lang, hindi mo nakita si P at saka si Q. Pero posibleng nag-e-exist siya, hindi lang natin alam, right? But the proof by contradiction gives us another power, right? Na sabi natin, o sige, kunwari, i-accept natin na pwede ko siyang isulat as an integer, as a rational number. So ibig sabihin, makakahanap ako ng butas or magkakaroon ako ng something contradictory to something that was previously established para masabi talaga na imposible na masulat siya as a ratio of two integers. So that's what we'll do. We'll try to write a proof by contradiction for this. Okay. So I'll start by the statement or my supposition that square root of 2 is rational. All right? Then ano yung pwede kong isunod? So i-assume ko for the sake of contradiction that square root of 2 is a rational number. Then what can be said about square root of 2? Any suggestions? Nandiyan pa ba kayo guys? Or na-disconnect ba ako? All right. Later, Neil, nakasagot ka na. So try kayong iba. But good to know that I'm still here. Oh, yes, Trisha. What can I say next?
Yung square root of 2 po ay pwedeng equal sa ratio ng dalawang integers. Wherein yung nasa ibaba na integer ay hindi equal sa 0.
Okay, thank you, Krisha. So that's right. Then it's rational. Distinguishing characteristic ng rationals ay kaya silang isulat as a ratio of two integers, the denominator of which is not equal to 0. Then, kunwari totoo ito na rational siya, so there should exist A and B in the set of integers. Hindi kailangan positive integers, but they are integers A and B, such that B is not equal to 0 and square root of 2 is equal to A over B. Okay. And then I can say further that this is in lowest terms. Okay. So para lang clear, kasi hindi unique yung pagsusulat sa fraction, tama? Yung 1/2, pwede mong isulat as 2/4. Or pwede mo rin siyang isulat na 3/6, right? So maraming representation ng isang fraction. But let's assume that square root of 2 is equal to A over B in lowest terms. Okay? Naka-lowest terms na siya, kunwari. And we can do this, right? Kahit anong rational number, kaya nating i-lowest terms. So parang distinguishing characteristic din siya ng rationals. Kaya natin siyang isulat as a ratio A over B in lowest terms. Okay? Then if this is true, right? So I can square both sides of the equation. Okay? So square root of 2 ay equal kay AB. So that means 2 is equal to A squared over B squared. Right? And then this will imply that 2B squared is equal to A squared. Okay? Puro algebra lang naman so far, wala pang mali. All right? Then at this point, what can I say from 2B squared being equal to A squared? Ano yung pwede kong masabi? Nag-stuck ba yung screen ko, guys? Or kita nyo pa ba? Hindi ko siya makita sa monitor ko. Yes, Bea?
Pwede po natin masabi na si A squared po ay even.
Thank you, Bea. That's right. Dahil si A squared ay equal kay 2B squared, we can say that A squared is even. All right? And then, ano yung pwede kong isunod na sabihin? Kung si A squared ay even, then... Yes, Crizel?
Then si A po ay even din. Ay even.
All right, thank you. That's right. Coming from the previous theorem, right? Yung illustration 30 or 31. Tama? Ang A dapat ay even. Okay? So, yon. And then so far, may problema ba tayo? Mukhang wala pa tayong problema so far, no? Wala pang contradiction. Actually, this is the problem with proof by contradiction. Hindi natin alam kung kailan tayo titigil. All right? So, hanggat wala kang nakikitang contradiction, hindi ka titigil. Kaya lang medyo may problema yon. Kasi tayo dapat yung makahanap ng contradiction. Wala tayong target in mind. Wala tayong WTS. Wala tayong we want to show that. Naghahanap tayo ng blanket contradiction. Okay? So far, inanalyze natin yung mga implications ng pag-assume na si square root of 2 ay rational. So far, wala pa tayong nababiolate. Alright? Ang alam lang natin, yung numerator dapat ni square root of 2 dapat ay even. Right? So yun yung sinasabi ng analysis natin so far. Okay. So kung siya ay even, so proceed ako. Ano pa yung pwede kong sabihin? Kung si A ay even, then ano yung pwede kong masabi? Any suggestion? Pero nakikita niyo pa naman yung screen ko, or nag-stuck ba siya? Nag-stuck kasi siya sa laptop ko sa B not equal to. Okay pa. Sa laptop ko lang yung may problema. Sige, antay lang ako ng iba, Axel, kasi nakasagot ka na. Pa may gustong humabol. Si Neil nakasagot na rin. Sige, dahil wala namang iba nagtatanong at nauna si Axel. Axel, ano yung pwede kong sunod na gawin? Sorry, Axel, parang grounded yung microphone mo. Static lang yung narinig. Can you try again?
There exists an integer k such that a is equal to 2.
Okay. Yeah, I think I got the gist of what you're saying. Kung si a ay even, dapat masulat ko to as twice another integer, right? I just didn't catch what variable you want to use. Pero sige, sabihin ko na lang there exists a k in z such that a can be written as twice k. Right? Yun yung ibig sabihin ng pagiging even. Okay, so far so good pa. Wala pa rin contradiction. Hindi pa rin ako titigil. Kaya lang, mabalik ako dito sa statement na to. So kung si a ay even, pwede siyang masulat as 2k. Si a ay 2k, so pwede ko siyang i-substitute dito sa equation na to. So it follows that 2b squared is equal to 2k quantity squared, right? Sinubstitute ko lang yung panibago nating expression para kay a. And then I'll expand that power. It will just be 4k squared. In summary, what we know right now is that 2b squared is equal to 4k squared. I can divide both sides by 2 and get b squared equals 2k squared. All right. And then what can I say about b at this point? Okay, sige. Go ahead, Neil. Neil, question?
Sir, pwede na po masabi na si B ay even, B squared ay even rin po. Tapos, yung B po is even rin po. Tapos may contradiction.
Okay, thank you, Neil. Yeah, that's right. Si B squared ay 2k squared. So ibig sabihin si B squared dapat even. So by the previous result, the same as what we applied to A, masasabi natin si B ay even din. And I will claim there is a contradiction here. Okay. Ano yung contradiction? Muntik nang madula si Neil, pero anybody who spot the contradiction? Sige, Prince. Nauna si Prince. Mga repeat ano na kayo, no? Mga repeat recitants. Recitants ba ang tawag? Oops, ano yung ginawa ko? Yes, habang nag-antay si Prince. Ano, type si Prince. Haba pala yung tinipe ni Prince, kaya medyo matagal. Yeah, thank you, Prince. Sabi niya, since both even po yung A at B, pwede pa pong ma-lowest term, which is nabanggit po na pwedeng ma-lowest term pa yung ratio ng dalawa. Rational po yun, which is a contradiction. So that's right, Prince. I think I got what you're trying to say. So si B ay even, si A ay even din. So that means, pwede kong isulat dito kung hindi pa clear yung contradiction. So, A and B are both even. That is, they share a common factor too. Alright? Dahil pareha silang even, so dapat meron pa silang common divisor. Divisor nilang dalawa, si 2. Pero sabi nga ni Prince, contradiction yon kasi in-assume natin kanina na yung A over B ay naka-lowest terms na. So kung si A over B ay naka-lowest terms na, and yet now, we are saying na may common factor pa pala si A at saka si B. And that is in contradiction to the supposition na dapat naka-lowest term na yung A and B. Okay? So and that ends the proof. So ibig sabihin, hindi pwedeng maging rational si square root of 2. Kasi kung maging rational si square root of 2, merong fraction na naka-lowest term na pero hindi pa naka-lowest term, which is absurd, right? So that's purely a contradiction. So kaya kailangan tanggapin natin na si square root of 2 ay hindi irrational. So sorry na lang sa mga Pythagoreans, right? So kailangan nilang tanggapin na hindi lahat ng numbers ay rational. Okay? And I guess you can imagine how difficult it would have been kung hindi proof by contradiction. I haven't encountered any proof yet that square root of 2 is irrational using a direct proof. Parang ito yung pinaka-popular na proof para sa square root of 2 being irrational. Actually, there's another nice proof na classically dinidiscuss via contradiction, yung infinitude ng prime numbers. So yung theorem ni Euclid, tama ba si Euclid yan? I think yeah, it's Euclid. There are infinitely many prime numbers. So medyo isang malaking fascination para sa mga mathematicians and even general public ang mga prime numbers. Sila yung mga numbers na hindi na pwedeng ma-factor or wala nang ibang factors aside from one in itself. Right? So parang pakonti sila ng pakonti kasi ang idea kapag ka lumalaki yung number, parang mas marami siyang candidates para maging factor, right? The first few prime numbers are 2, 3, 5, 7, 11, 13, and so on. Okay? Pero pag malaki na yung number, parang napakahirap ng maging prime number niya. Kasi napakarami ng candidates para maging factors. And yet, sabi ni Euclid or pinrove ni Euclid by contradiction that there are infinitely many primes. And just imagine how painful it would have been kung ipoprove natin siya using a direct method. Kung ipoprove natin siya na direct method, kailangan nating ipakita na infinitely many primes. And one way to show that there are infinitely many primes is to show a formula para sa mga prime numbers. Magkaroon ka ng t equals something something, siya ay prime number. And we show that merong infinite many results yung formula na yon. But actually, prime numbers are very fascinating kasi wala tayong expression para sa mga, or wala tayong formula para sa lahat ng prime numbers. Actually, there is a contest ng palakihan ng prime number. There's currently a search for the biggest prime number. Hindi nga lang masyadong updated, pero it was a big news when they found a very large prime number. Usually, computer search yung ginagamit nila. Pero alam natin na laging may tatalo dun sa record. Kahit hindi natin alam kung ano yung, kahit hindi natin, alam natin na infinitely many prime numbers, right? So, ibig sabihin, pag merong record ngayon for the biggest prime number, alam natin na may mas malaki pa doon. Ang problema, hindi natin siya alam kung sino siya. Pero the wonder of math, alam natin na may nag-exist na mas malaki. Hindi nga lang natin alam kung sino siya, pero ang point, merong nag-exist. That's why I think there's a prize for coming up with a larger prime number than what is currently on record. So parang isa siyang malaking contest sa computing community. All right? Kasi ang prime numbers, maraming applications. So, but unfortunately, I don't have the time to prove that there are infinitely many primes. And I think merong results, may mga minor results na kailangan na gamitin para ipakita na infinitely many prime numbers. For math and MST students, you will see this again in Math 103, Elementary Theory of Numbers. That's a good class, so enjoy nyo yun. Enjoy ko siya ng undergrad. For applied math peeps, pwede nyo siyang i-take as an elective or hanapin nyo na lang sa net yung pagiging infinite ng mga prime numbers. Okay? But this is yet another result that is proven by contradiction. All right? So let me see. I think we can stop here unless you guys have a question. May mga tanong ba? Oh, perhaps I'll end with two things on the disadvantages of a proof by contradiction. So yung proof by contradiction, parang madali siya, right? Base dun sa mga examples natin na nakita. Pero meron siyang mga disadvantages. Unang disadvantage niya, hindi natin alam kung ano yung hinahanap natin na contradiction. The contradiction can be anything under the sun, right? So kailangan mo lang talagang i-analyze yung implications ng supposition mo na mali yung theorem. I-analyze siya ng in-analyze in any direction you want. Makahanap ka lang ng contradiction. Walang specified contradiction na hinahanap. Okay? So yun yung problema. Wala kang target. So kailangan mo lang i-analyze yung mga statements ng i-analyze. Hanggat wala kang nakikitang contradiction, huwag kang titigil. Alright? So wala kang target, so mahirap. Mangangapa ka talaga sa dilemma paghanap ng contradiction. We are just lucky in the examples that we considered, parang yung natural discussion of things from the supposition using valid arguments ay nakakuha tayo ng contradiction ng madali. Pero sometimes mahirap makahanap ng contradiction because again, we don't know what we are looking for, right? So that's the first disadvantage. The second disadvantage is prone siya sa error. I mean, di ba naghahanap tayo ng contradiction? Naghahanap tayo ng something na magiging mali that will come out of the contradiction. Halimbawa, nagpo-prove ka ng isang inequality. Nag-proof by contradiction ka. In the middle of your analysis or in the middle of your proof, you committed a very tiny algebraic mistake. Tapos yung algebraic mistake na yon, siya yung nag-cause kung bakit ka nagkaroon ng contradiction. And you might be led to believe that you are done with the proof and you have done a good proof or you have written a good proof. Okay? Kasi nga nakahanap ka ng contradiction. Pero baka hindi natin namamalayan na yung contradiction ay hindi nanggaling dun sa supposition pero nanggaling siya sa human error. And it's actually hard to spot this kasi nga naghahanap tayo ng contradiction. So excited tayo pag nakahanap tayo ng contradiction. Okay? Meanwhile, sa direct proof, pag nakakita ka ng contradiction, pwede mo sabihin, hold on a minute, baka naman mali na yung ginagawa ko. Kasi totoo daw yung theorem, sabi ng teacher ko, prove the following. So dapat true yung statement, direct proof yung ginagamit ko, bakit ako nakakuha ng contradiction? So, babalikan mo, i-debug mo yung proof mo. Baka naman may algebra mistake ako or meron akong tiny mistake na nagawa sa ibabaw. That's good for a direct proof. Pero sa indirect proof, alam mo talaga naghahanap ka ng mali. Naghahanap ka ng butas. Naghahanap ka ng isang statement that go against the mathematics that we know. All right? Dahil nakakita ka ng contradiction, parang maluwag sa loob mo na tanggapin, ito yung hinahanap ko na contradiction. Not knowing that probably you have committed a mistake somewhere in the middle. So that means the contradiction is attributed directly to the mistake that you did and not to the actual supposition. And that will make your proof invalid. So yun yung dalawang bagay na medyo disadvantages para sa proof by contradiction. Okay? But there are some moments that we don't have any choice but to use a proof by contradiction. All right? So I think that's what I want to say. In the other class, I was able to tackle example 34. Pero basahin nyo na lang yung example 34 and then try exercise 33. So kung may time kayo, i-try nyo siya and then let me know on Friday if you had some difficulties with these two problems so I can probably go back to them and let's discuss them in class, right? But otherwise, I think it's a good place to stop. Do you guys have any questions? Any comments? Any suggestions? Oh, yes, Bea.
Sir, yung sa exam po next week, hindi po kasi ako nakaabot kanina nung nagdi-discuss po about it. Tanong ko lang po, sir, kung time po pa yung, may oras po ba yung exam na, or pwede pong i-download po yung prob set na sasagutan?
Oh, thank you, Bea. Good question. Pwede nyo siyang i-download. I-upload ko na siguro sa weekend yung problem set. Pero magiging accessible siya sa inyo Monday 8 a.m. So at Monday 8 a.m., pwede na kayong pumunta sa harap ng mga cellphones or laptops nyo. Download nyo na yung problem set. Okay? So pagka-download nyo, pwede nyo siyang gawin offline. Okay? Hindi ko naman kayo ita-time. So gawin nyo siya offline. Tapos ang deadline ng submission ay sa Wednesday, right before midnight. So meron kayong 4 na problems na sasagutan. And then at least may 2 magkaibang file kayo na isasubmit. Yung isa isasubmit nyo para sa akin, yung isa isasubmit nyo sa lab instructors, all via Canvas. Okay? Kami na yung magsasort. Hanapin nyo na lang kung ano yung appropriate link kung saan nyo i-upload kay Canvas yung sagot nyo. So mag-alat kayo ng konting time. Huwag naman yung buzzer beater na 11:58 kayo pumunta sa harap at mag-upload. Baka biglang mawala ng internet or whatnot. So yeah, mag-alat kayo ng konting oras. Hindi time yung exam, download nyo siya unlimited until 11:59 p.m. on Wednesday. Okay? Now, I suggest na kung natapos nyo na yung problem, pwede nyo siyang i-upload. Hindi pala, no? Okay. Kung natapos nyo na yung part ng problem na ako yung mag-check, sasabihin ko doon kung ano yung i-check ko. Halimbawa, sabihin ko, problem 1.4, yung ako yung mag-check. Kung tapos na kayo sa problem 1.4, pwede nyo siyang i-upload kagad kay Canvas, kahit hindi pa deadline. Tapos, kompletuhin nyo na lang yung kalahati na checkan ng lab instructors nyo bago nyo siya i-upload. Kasi ang maganda ay kapag nag-upload na kayo kay Canvas nung problem na checkan ko at wala naman akong ginagawa, baka checkan ko na siya kagad. You get your scores early if you submit early. Okay, so yun lang. Pero otherwise, that's it. Hindi time yung exam, pwede nyo siyang i-download, gawin offline. Alright? Tapos ang request ko lang pala ay, syempre wala naman akong magagawa kung magse-search kayo sa net or magko-consult kayo with each other. And actually, that's fine with me. That's part of my assumptions when I will be writing the problem set. So it's fine to you to go online kung na-stuck kayo, mag-search kayo, or you can also do the problem set as a group. Ang tanging request ko lang ay, yung sa isa-submit nyo, paki-indicate kung saang website nyo nakuha yung inspiration dun sa sagot nyo, or kung sino yung mga ka-study groups nyo. Okay? So i-acknowledge nyo lang sila. Cite your reference or cite your classmates that you worked with. Walang deduction. So mas ma-appreciate ko ngayon. Kasi at least alam ko kung paano nyo ginawa yung problem set. Okay? Wala naman siyang deduction, so why not declare it, right? And just make sure that when you write something, you understand what you wrote. Okay? Kung nag-group study kayo, i-try nyo na isulat siya on your own. And make sure that every point is clear to you. Huwag kayong papayag sa study group na sinabi ni classmate, eto, may contradiction na. Dapat ay huwag nyo lang basta kopyahin yung contradiction na yun. Kailangan tanungin nyo, bakit nagka-contradiction yan? So parang nag-aaral din kayo in the process. So don't accept anything just on its face. Tingnan nyo, bakit to totoo? At pag naintindihan nyo na siya, kahit nakita nyo siya sa internet or kahit sinabi ng classmate nyo, basta naintindihan nyo siya at sinulat nyo sa problem set, that's perfectly fine with me. Kasi ang idea ng problem set is to not only to test you, but also to teach you something, right? At masaya na ako pagka nasulat nyo siya kasi ang assumption ko, natutunan nyo na siya. Kasi I will trust you na hindi nyo naman siya isusulat nang hindi nyo siya naintindihan. Right? Okay, so yeah, I think that's it. Any other questions? Okay, so if there are none, so thank you guys for joining me today. Enjoy the rest of the night. Prepare for the problem set on on Monday. Again, also for the latecomers, worksheet number 6 is canceled. Don't worry about it for now. Just worry about the problem set, right? And yeah, let's see each other again on Friday. Bye, everyone. Oh, by the way, oh yes, yeah. Thank you, Neil. Yeah, yun yung susunod ko sa script ko. Yung mga nag-recite, so syempre si Neil. Bea. And who else? Sino pa yung hindi kayang mag-comment na nag-recite? Sila lang dalawa. So the others who recited verbally, please comment probably your nickname on the chat, right? Para ma-record ko siya. All right, guys. Bye.
Thank you po, sir.